Good day, students. Welcome to mathgotserved.com. In this clip, we're going to be going over how to factor difference of squares. This standard is covered in Algebra 1 and Algebra 2 courses. And don't forget, there are 14 practice problems at the end of this presentation that we'd like you to try out in order to demonstrate mastery of what we covered. If you'd like to gain access to our entire playlist or other valuable algebra learning resources, take a look at the link in the description below, or you can just visit our website at mathgotserved.com. All right, before we get started, let's go ahead and review the formula that's going to guide our problem solving process, okay? So the formula that we're looking at is the difference of squares formula. All right, so the difference of squares formula is given by a square minus b square. Okay, so if you look at the name, is called difference of squares. So you have two squares and they're subtracted from each other, and another word for subtraction is difference. Okay, so we have two squares that are subtracted from each other. The factored state is a plus b times a minus b, the product of the sum and the difference of the square root of the squares. Okay, so something you want to keep in mind, a common mistake that many students make, is that when you have a sum of squares, it's prime. Okay, so when it's prime, there's nothing that can be done to it. So difference of squares, remember the acronym DOS. When you have DOS, difference of squares, you can factor. When you have SOS, sum of squares, guess what? It's prime. What does prime mean? Prime basically means that it cannot be factored. So look out for this trick question in your practice problem set. All right, now let's review our squares first, and then we're going to take a look at our square roots and then attack the problem. Okay, so let's do a real quick refresher on our squares. So review on our squares. We're going to call them perfect squares. Okay. All right. So let's start from 0. What is 0 square? Well, 0 square just means 0 times 0, which is 0. And then 1 square is 1 times 1, which is 1. 2 square is 2 times 2, which is 4. 3 square is 3 times 3, which is 9. 4 square is 4 times 4, which is 16. 5 square is 5 times 5, which is 25. 6 square is 6 times 6, which is 36. 7 square is 7 times 7, which is 49. 8 square is 8 times 8, 64. 9 square is 9 times 9, which is 81. 10 square is 10 times 10, 100. 11 square is 11 times 11, which is 121. 12 square, which is 12 times 12 is 144. 13 square, which is 13 times 13 is 169. And then 14 square is 14 times 14, which is 196. And then the last one that you need to remember is 15 square. 15 times 15 is 225. Okay, so these are our perfect squares. Now, why is this important? Well, if you take the square root of these squares, what you end up with is the number that you squared to arrive at the square root. Alrighty? Okay. All right, so let's go ahead and test your knowledge. Okay, we're going to go over our square roots on the right here, and then we're going to use our square roots to guide our problem solving process. Alrighty. Okay, so let's see if you remember the inverse, the reversal of your perfect squares. Now, what is the square root of 0? Since 0 is a perfect square, the square root of 0 is 0. What is the square root of 1? Square root of 1 is 1. What is the square root of 4? Square root of 4 is 2. What is the square root of 9? Square root of 9 is 3. What is the square root of 16? That's 4. What is the square root of 25? All right, hopefully you see the connection, okay? The square root is the opposite of the square, so we're going backwards, okay? Square root of 36 is 6. The square root of 49 is 7. Square root of 64 is 8. So the goal is to have all of these mastered. You need to have them mastered so that it's easy for you to factor, okay? Square root of 81 is 9. Square root of 100 is 10. Square root of 121 is 11. Square root of 144 is 12. The square root of 169 is 13. Square root of 196 is 14. Square root of 225 is 15. Okay, all right, so these are the squares right here. So we're going to use them to solve the problems that we're working on. So instructions are to factor the following. Question number 1. Let's say we have b squared minus 9. So the first question you want to ask yourself is this a dose? Is this a difference of squares? Is b squared a square? Yeah, because b is being squared. Is 9 squared a square? Absolutely, because 3 times 3, or 3 squared, is 9. So what do we do here? All you just do, we're going to use a formula, okay? So you're going to square root the first and the last term, and then you're going to write it as plus or minus, the sum and the difference. Okay, so this is going to become the square root of b squared is just b, so you have b, and the square root of 9 is 3. So b plus 3, the sum of the square roots, and then b minus 3, the sum of the square roots. Okay, so this is a squared, b squared, a plus b, a minus b. Let's take a look at another example. Let's say we have to factor n squared minus 49. Now, is this a difference of square? Is this a dose? Is n squared a square? Yeah. Is 49 a square? Yes. So this is a difference of squares, so we can use the formula, square root the first and the last, and write it as a sum and a difference. Okay? All right, so this is going to become n minus the square root of 49. If you forgot, just look at our list here, 7. Okay? n plus 7 times n minus 7. The order that you write this, the product of these factors, doesn't really matter because multiplication commutes. Okay, now let's have the following problem, 121 minus z squared. What is this one going to be? Well, do we have a difference of squares here? Do we have two squares? Yes. 121 and z squared are both squares. Do we have a difference? Yes. So difference of squares, check. Let's factor square root the first and the last and write it as a sum and a difference. Okay, so it becomes 11 plus z times 11 minus z. Let's write our 11 properly. 11 plus z times 11 minus z. And there goes the answer to question 3. All right, moving right along. So when you get a hang of it, you can do this really, really fast, without a problem. Number 4, let's say we have e squared minus 144. Okay? All right, so hopefully you got the hang of it now. So if you want to factor e squared minus 144, you square root the first and the last, and then you write it as a sum and the difference. Okay, so this would be e plus 12 times e minus 12. All right, number 5. Let's say we have j squared plus 49. What is this one going to be? For j squared plus 49, the factored form is going to be j squared plus 49. Whoa, what just happened? Why is it exactly the same? Ladies and gentlemen, this is not a dose. This is not a difference of squares. This is a And so sum of squares, okay? So because the sign in the center is positive, this cannot be factored, it's prime because we have a sum of squares, okay? All right, so watch out for problems like that. Number 6, what if you have to factor 1 minus 16x squared? Let's take a look at that. So we want to factor 1 minus 16x squared, the same procedure. So you factor the first and the last term and write it as a sum and a difference, okay? So it's going to be 1 plus the square root of 16 is 4 times the square root of x is x. 1 plus 4x times 1 minus 4x. All right, moving right along. Let's take a look at question number 7. So for question 7, let's say we are to factor 25a squared minus 121. Okay, so let's do it. Now don't forget to check to make sure it's a dose. So do we have two squares here? Yes, these are squares. And this is a difference, so we can factor it. Square root of the first term is 5a plus the square root of 121, 11. If you've forgotten, you can just look at our chart here to help you out. Sum and difference. Number 8. Let's say we want to factor 16x squared minus 64. Now, does this look like a dose? Is this a difference of squares? It certainly is. These are all squares here. So when you square the first term, you have 4x plus 8, and then the square root of the second, and then you do, this is a sum, okay? And the difference is 4x minus 8. So you have the sum and the difference. For question 9, we have 144d squared minus 81. In this particular case, we have a difference of squares also. So when you take the square root of 144d squared, that's going to give you 12d, okay? Because the square root of 144 is 12, as you can see. Where is it? Right here. And the square root of d squared is just d, okay? Minus, plus the square root of 81 is 9. All right, so 12d plus 9 times 12d minus 9. Okay, let's move along to question number 10. So for 10, what if you were to factor m squared minus 100n squared? What is that one going to be? So let's do our check again. Make sure it's a difference of squares. Yes, it is. This is a square and a difference. So let's go ahead and factor that. So we're going to use the square root of the first and the second term. So the square root of m squared is m plus the square root of 100n squared. You do them one by one. The square root of 100 is 10. And the square root of n squared is n. Okay? Times n minus 10n. There you go. All right, number 11. So for number 11, what if we have 9e squared minus 49f squared? Let's take a look at this one. Do we have a difference of squares here? Absolutely. Okay, that's a square and a difference. So if you factor that, you're going to have 3e, that's the square root of 9e squared, plus the square root of 49 is 7, and the square root of f squared is f. All right, 3e plus 7f times 3e minus 7f. Bam, there you go. Moving along, number 12. What if you were to factor 36w squared minus v squared? All right, so sum and difference of the square roots of the square, so it's going to be 6w for the square root of 36w squared plus the square root of v squared is just v times 6w minus v, like that. All right, so we're going to show you two more examples, and then give you an opportunity to do some practice problems. Number 13, what if we have 1 minus q square y square? Okay, so what we have here is that a difference of square, 1 minus q square y square. Absolutely, 1 is a square. Remember, 1 square, 1 times 1 is 1. Okay, all right. So the square root of the first term is 1 plus the square root of q square y square. You square root them one by one is qy, and then times the difference, 1 minus qy. Okay, and number 14, what if you have 100m to the 4th minus 64? Let's go ahead and factor that out. Is this a difference of squares? It certainly is. So this is a square, that's a square. M to the 4th is a square too. As long as the power is even, then you know it's a square, okay? So let's factor this. The square root of 100 is 10m. So when you take the square root, you divide the power by 2. So that's m squared minus the square root of 64 is 8. Okay, and then you write down the difference, 10m squared minus 8. Okay, so there goes the tutorial. It's now going to be your turn to do some practice problems. Alrighty, now it's your turn to do some practice problems. We have 14 practice problems that we'll like you to factor out completely. Look out for prime expressions that are not factorable. So go ahead and pause this video presentation at this time. Factor all these 14 binomials, and when you're done, click on the play button and we'll reveal what the answers are. Alrighty, welcome back. So hopefully you had a chance to try the problems. Let's take a look at what the answers are. For number 1, the answer is y plus 2 times y minus 2. For number 2, it's k plus 8 times k minus 8. For number 3, it's 5 plus x times 5 minus x. For number 4 is d plus 10 times d minus 10. For number 5, it's 1 plus 7k times 1 minus 7k. For number 6, it's y plus 8 times y minus 8. For number 7, it's 2y plus 10 times 2y minus 10. For number 8, it's 8x minus, we just do plus 7 times 8x minus 7. For number 9 is 3a plus 11 times 3a minus 11. For number 10 is y plus 9x times y minus 9x. For number 11, it's 2k minus 5 plus 5t times 2k minus 5t. For number 12, it's 9s plus t times 9s minus t. For number 13 is 8y squared plus 3 times 8y squared minus 3. For number 14, it's yz plus 15 times yz minus 15. Okay, so how well did you do in these 14 practice problems? Let's know in the comment section below how well you did. If there are any questions or clarifications that you want on any of these examples or any factorization problem in general, just specify a comment in the comment section below and we'll be glad to assist. If you found the contents of this presentation helpful to you, do give us a like or a thumbs up. Your positive feedback was very valuable to us. Don't forget to subscribe to our channel for updates to other tutorials such as this. We upload videos to our page on a regular basis. As indicated earlier, if you have any questions or comments, just include it in the comment section below and we'll be more than glad to support you. Don't forget to check out our website, mathgotserved.com, for tons of support resources. Thanks again for watching and have a wonderful day. Goodbye.